morning students. Okay, so in today's class we are going to do exercise 4D and exercise 4C is left. In that exercise I will give you a photo of it is called as the sieve of Eratosthenes. So you have to choose the prime numbers from there's a list of numbers from 1 to 100 and from those numbers you have to circle the prime numbers. Okay, that's it. I mean that is only there in exercise 4C. So I will send you a photo of it. So that exercise and the next exercise is 4D. So we are going to do exercise 4D. So what is the first question? It is use a factor tree to find the prime factors of. So you have to find the prime factors of these numbers. We have seen what are factors of a number, and so today we are going to see what are prime factors. So prime factors means what? The numbers which are, or the factors of the number, like here the given numbers are 12, 65 and so on. So the factors of these numbers which are prime, okay, the factors which are prime numbers as well, okay. So we are going to see that, and they have told to use the factor tree. Factor tree means what? We just write the factors of the given numbers in a tree diagram format. So like I will show you. So this is one part and the other is the repeated division. So repeated division and factor tree is somewhat similar. I will show you the repeated division also, and here in this question they have told us to do with the tree factor tree diagram. Okay, so yes, the number is 12. So what are the factors of 12? If we take 2 and see, we have to go on dividing 12 by the smallest number. Okay, so the smallest number, not 1, after 1. Okay, so what is the smallest number after 1 is 2. Okay, so 12, can it be divided by 2? Yes, it can be divided by 2, right? So if I divide this 12, number 12 by 2, what do I get? 2 is one thing and the other is 2 into how much is 12? 2 into 6 is 12, right? So I have divided this 12 in two factors. One is 2 and the other is 6. So from these two numbers, from 2 and 6, which is the prime number? 2 is a prime number, right? 6 is not a prime number, it is a composite number. So we will circle the prime number. So we will circle 2. Okay. Now the next number is not a prime number, right? So we can further divide that number. So what into something will give me 6? So if I take 2, the smallest number, yes, 6 can be divided by 2, right? So 2 into how much is 6? 2 into 3 is 6, right? So now here I have got two factors for 6. One is 2 and one is 3. So 2 and 3 both are prime numbers now, right? So I circle 2 and 3. Okay. So what are the prime factors of 12? The prime factors of 12 are 2, 2 and 3. So the prime factors of 12 are 2, 2 and 3. Why? Because all these are prime numbers which we have got, right? So these are the prime factors of 12. Now we go to the second one. The second number is 65. So we start from the smallest number. Can this number be divided by 5? Can this number 65, can it be divided by 2? No, it cannot be divided by 2 because at the end there is not a, there's no odd even number. There's an odd number. 5 is an odd number. So like in short, 65 cannot be divided by 2. It cannot be divided by 3 also and by 4 also. So it can be divided by 5 only. So 5 into what gives me 65? 5 into 13 gives me 65. Okay. So 5 into 13 I get 65. Now you can see in this case that 5 is also a prime number. These two, 5 and 13, are the two factors which we have got for 65. Right. So in this case you can see that 5 is also a prime number and 13 is also a prime number. Right, because they do not go in any other numbers table. So they are called as prime numbers. So 5 and 13 both are prime numbers. So I circle them. So 5 and 13 are the prime factors of number 65. Okay. Now the third one. The third one is 24. So again we start from the lowest number, the smallest number. The smallest number, this 24, can be divided by 2, right? So I write 2, and 2 into how much is 24? 2 into 12 is 24, right? So the other factor is 12. Okay. Now 2 and 12 are the two factors which we have got for 24. Now out of these two, 2 is a prime number, right? So I circle it. Now that, okay, so 2 and 12 are the two factors of 24, out of which 2 is a prime number. Now 12 is not a prime number, it can be divided. So again we divide 12. So 12 can be divided by which number? We start from 2. So can 12 be divided by 2? Does 12 go in 2's table? Yes, right. So we can divide it by 2. So 2 into how much is 12? 2 into 6 is 12, right? So one factor which we get is 2 and the other one is 6. So out of these two, 2 is a prime number. So I circle 2. Now 6. Now 6 again it can be divided by 2. So I write 2 into how much is 6? 3. So 2 into 3 is 6. Now I have got two factors for 6 and 2 and 3 both are prime numbers, right? So I circle both of them. So what are the prime factors of 24? The prime factors of 24 are 2, 2, 2 and 3. Okay, 2, 2, 2 and 3 are the prime factors of 24. Now we go for 136. Now 136, yes, this number can be divided by 2, right? So I start dividing by 2. So 2 into how much is 136? 2 6s are 12, 2 8s are 16. So 2 into 68 is 136. Now 2 is a prime number, so I circle it. Now 68 again can be divided by 2. So we write 2 into how much is 68? 2 3s are 6, 2 4s are 8. So 2 into 34 is 68, out of which 2 is a prime number. Now again 34, 2 1s are 2, 2 7s are 14. So 2 and 17 I have got. So 2 is a prime number and 17. Is 17 a prime number? Yes, 17 is also a prime number. So I circle 17 also. Okay. So what are the prime factors of 136? 2, 2, 2 and 17. So all these are the factors of 136. Or you can even write them as 2 and 17. Because 2 is common, right? 2 is coming 3 times. So 2 and 17, here 2 and 3. Similarly here also 2 and 3 are the prime factors of 12. Here 2 and 17 are the prime factors of 136. Now I will show you how to do the factorization of this number 136 by this was done by prime factor tree method, right? Now this I will do by repeated division method. Okay, repeated division. So how to do that? That is also similar to prime factor tree, but it is little different. The arrangement is little different. Okay. So first what I do, first I write the number which is given. So 136 is given to me. Then I put it in a half box like this. Okay. Now 136 can be divided by 2. We know. We have to start from the smallest number. Okay. If it does not go in 2's table, then we go to 3. If it does not go in 3's table, then we go to the other number 4. Okay. But if it can be divided by 2, so we start dividing from 2 itself, from the smallest number. Okay. So 2, I start dividing by 2. Then 1 is smaller than 2. So I take 2 numbers together, 2 digits together. So 2 digits, if I take, the 2 digits form a number 13. Okay. So 2 into what gives me a number which is nearly equal to 13? 2 into 6 gives me a number which is 12, and 12 is nearly equal to 13. It should be equal to 13 or it should be lesser than 13. Okay. So 2 into how much is a number? 2 into 6 is 12, and 12 is lesser than 13. So 13 minus 12, how much is left? 1 is left. So 1 I will write here on the next number. So this number now becomes 16. So 2 into what gives me 16? 2 8s are 16, right? So 2 into 8 is 60. Okay, so the next number which we have got is 68. Now again, if we divide it by 2, this can be divided by 2, right? 68 can be divided by 2. So again, on dividing by 2, 2 into how much is 6? 2 into 3 is 6. Then 2 into 4 is 8. Okay. So the next number which we have got is 34. Now again 34 can be divided by 2. So we divide. 2 into 1 is 2. Okay. 2 into 1 is 2. 1 is left. So 2 into, now this number becomes 14. So 2 into 7 is 14. Okay. So now we have got 17. And 17 cannot be divided by any other number, right? 17 is a prime number. It does not go in any other numbers table. So, what into 17 into 1? Only 17 into 1 I will get 17. Okay. So, I have got what numbers to the left? I have got 2, 2, 2 and 17. So, I write them 2, 2, 2 and 17. So, all these are prime numbers. So this is the repeated division method, and this is the factor tree. Okay, so you can find the prime factors by this method also and by this method also. Okay, so normally we use this repeated division method. Okay, so this is just a simple way. See, if you see that we have got 2 and 68, here also we have got 2 and 68. Then the next we have got 2 and 34. Here also 2 and 34. Then the next 2 and 17, so 2 and 17, and then 17, 1 is 17. So the total, how many ever factors here we have got, those only factors we have got here also. So any by any method you can do this. Okay. Now we go to the second question. Now the second question is, what is the smallest number with, the first part says 2 different prime factors and the second part is 3 different prime factors. That means we have to find a number which is the smallest of all, which has 2 different prime factors. 2 different prime factors means if 2 is one prime number, then other prime number is 3, or the other prime number should be 7, or the other next prime number should be something else. Okay, so both the numbers should be prime, but they should be different. 2 and 2 cannot be taken. Okay. 3 and 3 cannot be taken. Okay, so it is 2 different prime factors. So we have to find a number which has factors which are different. Okay, and they are prime also. So that smallest number which we have to find. So what we will do is, we will see if we take 2 bigger numbers like prime numbers. Suppose first we take the 7, number 7, and second if we take number 9. Sorry, 9 is not a prime number. If we take suppose 11, so 7 into 11 will be what? 77. Okay, but we need to find, see, 77 will also be a number which is having 2 prime factors, right? If I write 77, the factors of 77 are 7 and 11, and 7 and 11 both are prime numbers. But the number which we have got, 77, is not the smallest. Okay, we have to find a number which is the smallest of all. The smallest number which has 2 different prime factors. So first, so what we will do, we will take the smallest prime numbers. Okay, so the smallest prime number, the first number is 2 and the second number is 3. Okay, so if we multiply 2 and 3, what do we get? 2 multiplied by 3 is equal to 6. Okay, so 6 is the smallest number which has 2 different prime factors. Okay, if we check a number lesser than 6, if we number lesser than 6, which numbers are lesser than 6? 1, 2, 3, 4 and 5. All these numbers are lesser than 6. But do they have factors? Does 1 have a factor? Does 2 has factors? No. 3 has factors? No. 4 has factors. 4 can be separated as 2 into 2. But here, both these numbers 2 and 2 are same. Even though they are prime, but they are same, right? So, 4 is a number which has 2 factors, but those 2 factors are same. Okay? Then if we go to 5, 5 also doesn't have factors. So, the smallest of all, the smallest number is 6. After 6, there may be many numbers which have factors which are prime numbers. Okay? So, 6 is the smallest of all. So, how have we chosen 6? We have taken the 2 smallest prime numbers. So, after 2, first we took 2 which is the smallest prime number. After 2, we have taken the next one which is 3. Okay? So multiplying these two, we get a number which is the smallest number having 2 prime factors. Okay. Now the second one, the second part says that here's as they had asked us to write a number which was smallest and was having 2 prime factors. Here we have to write 3 prime factors. Okay, there's only this difference between the two. Here we have to write 3 prime factors whose multiplication will give me a number which is the smallest of all. Okay, smallest of all means all the numbers which have 3 factors, but they are prime also, and that number also should be smallest. So which number would be? For this also we have a trick. Like here we had taken the first 2 small prime numbers. In this part we will take the first 3 small prime numbers. So what are the first 3 small prime numbers? The smallest of all is 2. Then we have 3, and after 3, which number it is? 4. 4 is not a prime number, so we cannot take 4. Then we take 5. 5 is a prime number, right? So we take 5, and we have to multiply them. So I multiply 2 into 3 into 5. So what do we get? 2 into 3 is 6. Then 5 6 is 30. So the number is 30. So 30 is a number which has 3 smallest prime factors, 3 numbers, 3 prime factors, and they are different. Okay, 2, 3 and 5 all are different numbers, and they are prime also. So these 3 are the factors of 30. So 30 is the smallest number with 3 different prime factors. Okay, so what have we done? What was the trick here? We used 3 smallest numbers, prime numbers. Okay, and here we used first 2 small numbers, prime numbers. So the first smallest prime number is 2, and the next is 3. So 2 into 3 gives me 6. So 6 is the smallest of all numbers which have 2 different prime factors. So this was the second question. So with this we end the exercise. We will meet in the next class. Okay students, till then take care, goodbye.